Okay, so just to recap then, in general, if the equation is written either as 1 over a, or in other words a multiplier here, times y equals f of bx, then the way we look at this multiplier, either here in front of the y or the b, is that it seems opposite to what you'd expect. So if this value happened to be 2y, so just let's write 2y equals f of 1/3 x. Excuse me. Then really what this means is this multiplier is affecting the y. This is actually a vertical stretch, but it's by a factor of 1/2. So in fact it's a compression. And these vertical stretches are always centered or about the x-axis. Here you've got a third x. This is actually, when it's dealing with x, the multiplier is beside x. It's, again, opposite to what you'd expect. This will be a stretch by a factor of 3. It's actually a expansion by a factor of 3, and it's horizontal about the y-axis, or centered on the y-axis. So if it's written in this sense here, y equals af of bx, then because a is no longer with the variable y and you brought it to the other side, a does what you'd expect. This would have been, now this 2, if I brought it over, it would be landing here. I'd be writing it as y equals 1/2 f of 1/3 x. So this actually does what you'd expect. It is a vertical, but it's by a factor of 1/2, so it's a compression. You're compressing it by 1/2. This, because it's beside the variable, does opposite to what you'd expect. It is an expansion by a factor of 3, horizontal. Okay, so that's what this is explaining. So let's go on and look at class example number 1. Okay, so write a replacement for x or y and write the equation of the image of y equals f of x after each transformation. So the transformation here is there's going to be a horizontal stretch by a factor of 6 about the y-axis. So it's a horizontal stretch. It's going to affect the x value. So x goes to 1/6 x. That 1/6 will go in here and replace the original x. And because it's beside x, it does the opposite of what you'd expect. Instead of a compression, it's actually an expansion by a factor of 6 about the y-axis. That makes it a horizontal stretch. So it's getting elongated along in the direction of the x's, in both negative and positive, depending on where it's located. Next one is a vertical stretch by a factor of 1/5 about the x-axis. So if it's a 1/5, that means we can write it as y goes to, opposite of what you'd expect, 5y. When it's beside the variable, it looks opposite. This can be brought over, of course, to the other side, like this, and it will look like y equals 1/5 f of x. Or it could be written like this too. A reflection in the x-axis, and then a vertical stretch about the x-axis by a factor of 3. So first of all, a reflection in the x-axis. What does that mean? Remember, if you're reflecting any graph or any points from one side of the x-axis to the other, what changes? The y's become negative. So that's the first thing we've got to do. And then the second part, a stretch about the x-axis by a factor of 3. So if you're stretching about the x-axis, have a think. What's that? Is that horizontal? But it's vertical. It tells you actually here. It's going to be a vertical stretch. So again, we are affecting the y's. If it's a vertical thing we're changing. Now it's by a factor of 3. So if you're writing the variable, if you're writing the factor beside, or the multiplier beside the variable, it's opposite to what you'd expect. So y becomes 1/3 y. So what's happening here is that y goes to negative y, and then this y gets replaced by a third y. So it becomes negative a third y. And here we have it here. So we have both a reflection in the x-axis and a vertical stretch by a factor of 3. So of course this can replace y now over here, or bringing it to the other side, it becomes negative 3 f of x. D, a horizontal stretch about the y-axis by a factor of a half, and a vertical stretch about the x-axis by a factor of a quarter. Well, if it's a horizontal stretch about the y-axis, you're affecting x. This will affect x, and it's by a factor of a half. So beside x, you're going to write x goes to 2x. You're going to put a 2 beside the x. That takes care of stretch of a half. And if it's a vertical stretch, you're going to put the multiplier beside the y by a factor of a quarter. So write 4y. So replacing these two, where we see y and where we see x, these get replaced. Of course we can divide both sides by 4, or multiply both sides by a quarter, and we get this. This is typically how we see equations. Solve for y. So here y equals a quarter, that means it's a vertical. This number here, whenever we see it written like this, is the vertical. So it's a vertical stretch by a quarter, and a horizontal stretch by a half. So get into the way of reading this in this fashion, that this means what it says. It's a stretch by a quarter, affects the y, so it's about the y-axis. Sorry, the x-axis is a vertical stretch, so it has to be centered on the x-axis. Bit of confusion there, but yes, you'll be stretched up or down, but it's centered on the x-axis. This is a horizontal because it affects the x, and it's opposite to what you'd expect, so it's a stretch by a half in the horizontal direction. So another way of asking a question like this is, how does the graph of 3y f of x compare with this, the original graph? Well, the multiplier is beside the y, so it's opposite to what you'd expect. It's actually a stretch by a factor of a third, and it's multiplying y, so it's a vertical stretch by a third. And we can drop this whole thing about the x-axis, because vertical stretches are always about the x-axis and horizontal stretches are always about the y-axis. So don't worry too much about this. When you turn to a graph, you'll know what to do. Example 3. What happens to the graph, the original graph, y equals f of x, if you make these changes? If you replace x with 4x, this is going to be horizontal. And because it's right beside the variable, it's opposite to what you'd expect. It's a stretch by a quarter horizontally. Don't worry about this. Replacing y with the third y, again it's beside the variable, so in this case it's opposite what you'd expect. It's by a factor of 3, and it's a vertical, because it's dealing with y here, vertical stretch by a factor of 3. Vertical by a factor of 3. How about replacing y with 6y and x with a third x? So here we're going to get a vertical stretch by a sixth and a horizontal stretch by 3. Okay, last example, class example 4. The graph of y equals f of x is shown. That's the thin line that you have on your workbook. I've plotted the points in blue here. We have to sketch y equals f of negative 2x. So x has been replaced by one thing, by negative x, and then x has been replaced by, this has been replaced by negative 2, so we get negative 2x. Okay, fair enough. We can summarize it like that. Now we should be able to see that, okay, this is affecting the x. First of all, the 2 means it's a horizontal stretch by a factor of a half. So horizontal stretch, factor of a half. This negative means it's a reflection. Where? In the y-axis. Okay, in the y-axis. When you make the x's negative, it really means you're taking x's on, say, this side, positive 3x, and reflecting it over here. It's now negative 3x, so you're making the x's negative. What does that mean? You're reflecting the y-axis. I have to keep telling myself that each time sometimes. Okay, so that's all that is. Okay. So please do all the questions in this assignment, and we'll see you in class.